Welcome to Module S4 of the Qlause Safety Series, Machine Safety and Lockout Tagout. Machines are the muscle of every plant, and the parts that do the work are the parts that can hurt you fastest. In the next few minutes, we'll cover how machines injure people, why guards exist and must stay on, the hidden energy that a switched-off machine can still hold, and the disciplined routine lockout-tagout that makes a machine truly safe to work on. This is an awareness module. It teaches you to respect these dangers and stay clear of them. Performing lockout itself is trained, certified work. Let's begin. Here's what you'll be able to do by the end of this module. First, you'll recognize how machines actually cause harm, the danger zones where bodies and moving parts meet, so you can keep clear of them by instinct. Second, you'll understand guards, what they do, why they're never optional, and why a guard that's awkward is a conversation, never a component to remove. Third, you'll understand hidden energy, why a machine that's switched off is not the same as a machine that's safe, and what lockout and tagout are for. And fourth, you'll know exactly where your line is, what general awareness gives you, and where a job crosses into certified, authorized work that only trained people may do. Let's start with why machine safety earns its own module. Across every industry, moving machinery is one of the largest single causes of serious injury at work. Crushed hands, amputated fingers, lost limbs, and worse. And here's the hard truth. The machine is not out to get you, and it is not careless. It is faithful. It does exactly what it was built to do, every time, without pausing, without noticing you, without mercy. A moving part cannot tell the difference between the material and your hand. That's not a reason to fear machines. It's a reason to respect them precisely, and to understand the two things that stand between them and you: guards and the discipline of isolating energy before you reach in. So here is the ground rule of this whole module. Off is not safe. Isolated and locked is safe. A machine at a standstill looks harmless, but a switch can be knocked, a timer can fire, a colleague can hit start not knowing you're inside the danger zone, and a part held up by nothing but its own weight can drop the moment a jam clears. The only machine you can trust with your hands is one whose energy has been positively cut off, locked in that state, and proven dead. Everything else in this module is built on that one sentence. A stopped machine is not a safe machine until it's locked. So how, exactly, do machines injure people? Almost all of it comes from a short list of mechanical hazards. Learn the family names and you'll spot the danger zones on any machine. There's cutting and shearing, blades, saws, and edges that come together. There's crushing, a moving part closing against a fixed one, or against another moving part. There's the in-running nip, the point where two rollers, gears, belts, or chains draw inward and pull anything they touch straight in. There's entanglement, rotating shafts, drills, and spindles that catch a sleeve, a glove, hair, or a lanyard and wind it up in an instant. And there's impact and ejection, a part that strikes you, or material thrown out of the machine. Every one of these lives at a specific spot. That spot is the danger zone. Learn where it is on your machine. The first thing standing between the danger zone and you is a guard. And guards are engineering controls, which means they protect you whether or not you're paying attention. That's exactly why they sit near the top of the hierarchy of controls, far above a sign or a rule. You'll meet a few kinds. Fixed guards, a barrier that simply stays in place and keeps you out. Interlocked guards. Open the gate and the machine stops. It won't run with the guard open. Adjustable and self-adjusting guards. They move with the material but still cover the dangerous part. And presence sensing devices. Light curtains and mats that stop the machine the instant something enters the zone. You don't have to memorize the catalog. You just have to understand what every one of them is for. To keep your body out of the part that bites. Now the hardest rule to keep, because it's the one production pressure attacks. Guards stay on. Every guard, every interlock, every light curtain on your site exists because a specific injury happened to a specific person. Somewhere. Once. The guard is the shape of that old injury, turned into steel and plastic so it never happens again. So never remove a guard to work faster. Never bypass or trick an interlock so the machine runs with the gate open. Never wedge, tape, or defeat a sensor. If a guard is missing, damaged, or in the way of doing the job properly, that is not yours to remove. It is a stop and report immediately. An awkward guard is a problem to raise. It is never a part to take off. Let's name the exact moment machine injuries happen, because it's almost always the same one. It is rarely during normal running with the guards closed. It's the interruption. The machine jams, and someone reaches in to clear it. A part needs cleaning or adjusting, or a quick look, so a hand goes past the guard just for a second while the machine is still live. That reach into a machine that is switched off but not locked, or still running but only for a moment, is where fingers and hands and lives are lost. The temptation is completely human. It's quicker, the machine looks still, you've done it 100 times. But this is precisely the moment the ground rule exists for. If your hand has to enter the danger zone, the machine gets locked out first. No exceptions, no just this once. Here's the part that surprises people, and it's the reason lockout exists at all. A machine that is switched off can still be full of energy, waiting, stored, ready to move the instant it's released. Off is not empty. There are 6 kinds of stored energy to respect. Electrical, capacitors and circuits that hold a charge after the power's cut. Mechanical, springs and tensioned parts under load. Hydraulic, fluid held under pressure. Pneumatic, compressed air, which can drive a part hard even with the power off. Gravity, a raised ram, arm, or load held up by nothing but position that drops the moment its support is released. And thermal, surfaces and fluids still dangerously hot. Cutting the power switch deals with only the first of these. Making a machine truly safe means finding and releasing every one of them. That's what the routine on the next slides does. So let's define the routine by name: lockout and tagout. Lockout is the physical act. After a machine's energy sources are switched off and isolated, a lock is placed on each isolation point so it physically cannot be turned back on. Not a note, not a promise, a real lock, and the person doing the work holds the only key. Tagout is the information. A tag on that lock names who applied it, when, and why, so nobody is left guessing whether a machine is safe to energize. The lock makes it impossible to start. The tag makes it clear why. Put simply, the whole discipline is 4 moves. Isolate the energy, lock it in the off state, tag the lock, and then verify that the machine is truly dead before any work begins. Let's talk about the lock itself, because it carries a simple, unbreakable principle. 1 person, 1 lock, 1 key. The lock you apply is personal. It protects your body, and you hold its only key. That means nobody else can remove it, and nobody else can start that machine while your lock is on it. When several people work on the same machine, each person applies their own lock, so the machine can't come back to life until every last worker has removed their own, often using a shared hasp that only opens when all the locks are off. And the rule that flows from this is absolute. You never, ever remove a lock that isn't yours. Someone else's lock stands for someone else's hands, somewhere inside that machine. Their lock is their life. You leave it exactly where it is. Here's the routine an authorized person follows, in order. 6 steps, and the order matters. Step 1. Prepare and notify. Know every energy source on the machine and tell everyone affected that it's going down. Step 2. Shut down. Stop the machine properly, using its normal controls. Step 3. Isolate. Turn off and disconnect every energy source you identified. The main switch, the valves, the supplies, all of them, not just the obvious one. Step 4. Lock and tag. Apply your personal lock and tag to each isolation point. Step 5. Release stored energy. Bleed the pressure. Block or lower raised parts. Discharge the circuits. Let hot surfaces cool. Make the stored energy from the last slide safe. And step 6, the one people skip, and the one that saves lives. Verify. We'll give that its own slide, because it's that important. Step 6 is verify, and it is the single most important step in the whole routine, because it's the one that catches every mistake made in the first 5. Verifying means proving with your own eyes and hands that the machine truly cannot move and holds no dangerous energy. You confirm the isolation is real, then you try to start the machine using its normal controls, expecting nothing to happen. If it stays dead, your lockout worked. Then, and only then, you return the controls to off and begin. This tryout step exists because you can do everything else perfectly and still have isolated the wrong switch or missed a second energy source. Verification is the difference between believing a machine is safe and knowing it. Never take zero energy on trust. Prove it. Now the boundary this whole module turns on. Who is actually allowed to lock out a machine? There are 3 roles. The authorized person is the one trained and formally appointed to isolate and lock out a specific machine, and to work on it. This is certified, competent person work, learned on real equipment, not from a video. The affected person operates or works near a machine that gets locked out. They need to understand what a lockout means and to never interfere with it, but they don't apply the locks. And everyone else simply needs to recognize a locked out machine and stay well clear. Where do you fit? Unless your site has formally trained and appointed you as authorized for a given machine, you are affected or other, and your job is respect and distance, never a shortcut through someone else's lockout. Even when you're just running a machine normally, a handful of habits keep you out of the danger zone. Dress for the machine. No loose sleeves, no dangling cords or lanyards, no jewelry, and hair tied back near anything that rotates. An in-running nip needs only a thread to start pulling. Gloves are a special case. Near rotating parts, they can be dragged in, so follow your machine's rule on when they come off. Know your stops. Before you start a machine, know exactly where its emergency stop is and how to hit it without thinking. Never distract an operator, and never let yourself be distracted at the controls. A startled hand is a hand in the wrong place. And never start a machine until the guards are in place and everyone's hands and bodies are clear. Call your start and look before you press it. So, what do you do when the picture isn't right? A few situations are always a stop and report. No judgment call, no waiting. A guard is missing, damaged, propped open, or has clearly been bypassed. A machine starts on its own, keeps running after you stop it, or behaves in a way it shouldn't. You see someone reaching into a machine that hasn't been locked out. Say something right then before the reach becomes an injury. In every one of these, the moves are the same. Stop the task, keep yourself and others clear of the danger zone, and report it immediately to your supervisor so the machine can be taken out of service and made safe by someone authorized. A machine that isn't behaving is a machine nobody touches until it's understood. Before we look at the law, let's gather the behavior of this whole module into 3 habits you can carry onto any floor in front of any machine. 1. Guards stay on. You keep your body out of the danger zone, and you treat a defeated guard as an emergency, not an inconvenience. 2. Energy gets locked. You understand that off isn't safe, and that any hand entering a machine means that machine is isolated, locked, and its stored energy released first by someone trained to do it. 3. Zero gets proven. Nobody trusts a machine to be dead. They verify it. Guard it, lock it, prove it. 3 moves. If everyone in front of a machine lived only by those 3, the danger zone would stay empty of hands. One honest note about the law. The principles in this module, guard the danger zone, isolate and lock the energy, verify zero, are true everywhere, but the detailed rules are local. In South Africa, the Occupational Health and Safety Act and its driven machinery regulations govern machine guarding and isolation. In the United States, OSHA's machine guarding standards and its control of hazardous energy, or Lockout Tagout, standards set the requirements. Across Europe, the Machinery Directive covers how machines are built and guarded, and the use of work equipment rules cover how they're used and maintained safely. And ISO 45001 wraps these same duties into a safety management system. Everything you've learned today is required, in some form, by all of them. But your site's own machine-specific procedures, written for your exact equipment, always come first. Let's be precise about what you've just done, because the boundary is a safety control in itself. This module is awareness training. It teaches you to recognize the danger zones, to respect guards and never defeat them, to understand hidden energy, and to know why lockout exists, the foundation every worker on a floor with machines needs. What it does not do is authorize you to lock out and work on a machine. That authority comes only from formal, machine-specific, competent person training applied to your actual equipment, arranged by your site before you ever place a lock. If a task means reaching into a machine and you haven't been trained and appointed for that machine, that's a boundary. Respect it and say so out loud. Knowing the edge of your training is competent. Let's land the 5 things worth keeping from this module. 1. Machines hurt people at the danger zone, the cutting, crushing, nipping, and entangling points, so keep your body clear of them by instinct. 2. Guards stay on. A guard is an old injury turned into a barrier, and a defeated guard is an emergency. 3. Off is not safe. A switched-off machine can still hold electrical, mechanical, hydraulic, pneumatic, gravity, and thermal energy. 4. Lockout, tagout, and verify is how a machine is made truly safe to work on. One person, one lock, one key, and never someone else's lock. And 5. Above all, performing that routine is trained, certified work. Know your line, respect it, and never reach past it. That's the end of Module S4. Thank you for giving machine safety your full attention, because this is a topic where attention is the whole job. 3 things before you go. First, download the free companion pack for this module at Qlause.app. It includes the 10-question quiz, a 1-page toolbox-talk summary you can run with your own team, an attendance register, and a machine safety and lockout awareness checklist. Second, this is Module 4 of a series. Next up is S5, Fire Safety and Emergency Preparedness. And third, remember the 3 moves in front of any machine. Guard it, lock it, prove it, and never put a hand where you haven't first removed the danger. Stay sharp, look after each other, and we'll see you in Module S5.